Okay, so we're going to start chapter 6 on quadrilaterals. But before we start on quadrilaterals, I just want to get kind of the big picture and talk about polygons. And what is a polygon? What is not a polygon? What do we know about interior and exterior angles? So a polygon is a closed figure formed by a finite, that means it has an actual number, of coplanar segments such that the sides have a common endpoint, are non-collinear, and each side intersects exactly two other sides, but only at their endpoints. So first of all, we need to have straight lines, so that's why you can see this shape is not a polygon. Here, this is a polygon because it's closed, okay? It's almost easier to look at what's not a polygon. So like when you have intersecting lines, now this would be two separate polygons because each one is a triangle, but the shape itself is not. You can't have anything where the sides don't meet, right? We already talked about you can't have anything with curved lines. So convex versus concave. Convex says no line containing a sides contains a point in the interior of the polygon. So in other words, imagine if you extend each of these sides, right? It doesn't go, the actual sides don't go through the polygon. So that's how we know it's convex. Concave, however, if we look at the sides and extend them, see how that side, it cuts through the polygon. This side goes through the polygon. So that's how we know it's concave versus convex. Polygon interior angle sum. So the sum of the angle measures of a polygon is the sum of the angle measures of the triangles formed by drawing all of the possible diagonals from one vertex. That's important. So basically the triangles drawn from one vertex. So let's just take a look at some examples. So a triangle, we should know all the angles have to add up to 180 degrees, right? So now in a quadrilateral, if I extend, there's only, from one vertex, there's only one way I could draw a diagonal. So this is 180, this is 180. So the whole thing altogether is 360 degrees. For a pentagon, let's say we start from this vertex, we draw two diagonals. So now I have 3 times 180, right? 3 triangles. So we get 540. So the angles on the inside of a pentagon add up to 540, and so on. So now we have a hexagon. There are 1, 2, 3, 4 triangles. So 4 times 180 is 720. So a hexagon adds up to 720. So basically, we could actually see a pattern here. So for a triangle, of course, it's 1 times 180. For quadrilateral, it was 2 times 180. Pentagon 3, hexagon 4. So we can follow in that same pattern. So let's look at the next page. So we already said here, this is 180. Quadrilateral, we said 2 times 180, which was 360. Here, we had 3 triangles, so that added up to 540. 4 triangles in a hexagon added up to 720. A heptagon has 7 sides, so this has 5 triangles, so 5 times 180 is 900. Octagon has 6 triangles, so 6 times 180 is 1080. A nonagon has 7 triangles, so 7 times 180 is 1260. A decagon has 8 triangles, so that's 1440 degrees. And then dodecagon has 10 triangles, and so 10 times 180 is 1800. Now, okay, so what we're basically looking for is a pattern relating the number of sides to the number of triangles. So if you look at each of these and the number of sides, it's always 2 less than. So if there's n sides, then there are n minus 2 triangles. Therefore, the sum is going to always be n minus 2 times 180, because that's how many triangles. So the sum will have to be the number of triangles times 180 degrees. So this is our interior angle sum. Again, this is going to be true for convex polygons only. And here it is, n minus 2 times 180. So let's take a look at example 1. Find the measure of the sums of the interior angles of each convex polygon. So basically any polygon after 12 sides, we just put GON, so a 16-sided polygon. So S is equal to 16 minus 2 times 180, so 14 times 180. So that gives us 2,520 degrees. Next one is an 8x-sided polygon, so it has a variable. So that's fine. We're just going to put the 8x minus 2 times 180. And the only thing we could really do here is just distribute. So we're going to take 8x times 180, so that's 1,440x minus 360. And we can't combine those because we don't have like terms. All right, example 2. Find the measure of each interior angle. So first thing we need to do is figure out how much does this whole thing add up to. So we have 1, 2, 3, 4 sides. So if we have 4 sides, quadrilateral adds up to 360. So I know 2x plus 2x plus x plus x has to be 360 degrees. So I have 6x equals 360. So x equals 60. So measure of angle A is 60 degrees. Measure of angle D is 60 degrees. But then B and C are 2x, so these are 120 and 120. And you can double check, add up all the angle measures, and just make sure they do add up to 360. Next one. Same idea, but this time we have 1, 2, 3, 4, 5, 6. So just remember the sum is 6 minus 2 times 180, because that's a hexagon. So 4 times 180 is 720. So I know I have all of these angles. Now I have 4 that are all the same. I have 4 angles that are 9x plus 30, and I have 2 angles that are 2x. So all of those combined has to add up to 720. So I'm going to distribute here. 36x plus 120 plus 4x equals 720. So we have 40x equals 600. So I'm going to divide, and we get x equals 15. So I know J and M are 2 times 15, so those are 30 degrees. So here, these two are 30. And then all the other angles are 9x, so 9 times 15 plus 30. So 9 times 15 plus 30, that gives us 165. So all of these are 165 degrees. Again, you can add all those up, make sure they add up to 720 to make sure that we didn't make any mistakes there. All right, next we have a regular polygon. So the definition of a regular polygon, first of all, it must be convex, and all the sides are congruent and all the angles are congruent. So we would say, basically, an easier way to say this would be it has to be equilateral and equiangular. So here's a regular pentagon, so we can see all the sides are congruent, all the angles are congruent. You want to think about like what would be a regular quadrilateral? Well, that would be a square. That's another example, right? All the angles are congruent and all the sides are congruent. So those are examples of regular polygons. Now, interior angles versus of a regular polygon, excuse me. The measure of an interior angle. That's one interior angle. Well, we know what the sum is, right? The sum was equal to n minus 2 times 180. That's for all of them. Now imagine that all of them are the same. So we have n minus 2 times 180, and we're going to divide by the number of sides. So when we want just one interior angle, and notice it has to be regular, otherwise we can't assume that that's the formula we're going to use. So example 3, the measure of an interior angle of a regular polygon is given. Find the number of sides, so that's n, in each polygon. So I know n minus 2 times 180 over n has to equal 135. So I'm going to multiply both sides by n, or think of, you can put that over 1 and cross multiply. So I have n minus 2 times 180 equals 135n. I'm going to distribute on the left side, so I have 180n minus 360 equals 135n. So now I'm going to add 360 to the other side, and I'm going to subtract 180n minus 135n. So we get 45n, divide both sides by 45, and we get n equals 8, or an octagon. Okay, next one. If you want to pause it and try this one on your own, then I will go ahead and solve it. So it's n minus 2 times 180 over n has to be equal to 156. So n minus 2 times 180 equals 156n. Distribute 180n minus 360 equals 156n. So add the 360 to the other side. Move the 156, so we get 24n equals 360. Divide both sides by 24, and we get 15. Next, we want to look at exterior angles and examine the sum of the exterior angles. So we're going to use regular polygons just as some examples. So what we want to do is we want to extend one side at each vertex. So if this is an equilateral triangle, each of these would be 60, right? So if we extend one side, this makes a linear pair, so that would be 120. Extend one side, that would be 120. This would be 120. So if we look at all the exterior angles, 120 plus 120 plus 120, the sum of the exterior angles is 360. Let's take a look at the next one. Again, we're going to assume this is a regular polygon, so we're going to assume all of these are right angles. So I'm going to extend one side, so that has to be 90. Extend one side, 90. Extend one side, that's 90. 90. So if I add 90 plus 90 plus 90 plus 90, I get a sum of all the exterior angles is 360 again. So I increased the number of sides, but it didn't change the sum. Now let's say we have a regular hexagon. So in a regular hexagon, the sum has to be 720, so we divide by 6. Each of these is 120 degrees. So if I extend each vertex one direction, I get all my exterior angles is 60 degrees. So I have 6 of them times 60. So again, my sum is 360 degrees. Now these are just examples with regular polygons, but we can do this for any convex polygon. And that brings us to our exterior angle sum. So if it's convex, then the sum of the exterior angles, one at each vertex, has to be 360 degrees. Now if we extend that to the next part, the measure of one exterior angle of a regular polygon, well, if we know they all have to add up to 360, we divide by the number of sides and we'll get the measure of one exterior angle. Okay, example 4. Now, just a reminder, before I move on, I want to go back to this picture here. If you notice the interior and exterior angle, if we add those up, what are we always going to get? We get a linear pair, which is 180. Which brings us to our next example, because we're going to ask to find the measures of each exterior angle and each interior angle for a regular polygon. So once we find one of those, we can find the other. So let's start with the pentagon. So n equals 5. So if I'm finding one exterior angle, that's going to be 360 divided by the number of sides, which is 5. That gives us 72 degrees. Now I could go back to this formula here, n minus 2 times 180 divided by n to find the measure of one interior angle, or I can use the fact that they form a linear pair. So my interior angle is actually just going to be 180 minus 72, which is 108. Next one, dodecagon. So this is when n equals 12. So my exterior angle is going to be 360 divided by 12, so that gives us 30. And then my interior angle, that's going to be 180 minus 30, so 150 degrees. Okay, the last example, find the measures of an interior angle and an exterior angle given the number of sides of each regular polygon. So this is basically the same exact example, just the only difference is this one I gave you the names. Here I gave you, n equals 20. So I'm going to do the same thing. Exterior angle is 360 divided by 20. So 360 divided by 20 is 18. And so therefore my interior angle is 180 minus 18. So 180 minus 18 is 162. Here, 18 sides, my exterior angle is 360 divided by 18, so I get 20. And then my interior angle, I get 180 minus 20 is 160. So here's your next homework assignment at the bottom of the page. Go ahead and work on that, and we will go over questions next class.